Yesterday, we started practicing factoring with expressions that start with a number. So take a look at number 1. This starts with a 2x squared. We learned a couple of different techniques we can use to cope with the fact that there's a number in the front of this. One of our techniques, bless you, Marcus, one of our techniques lets us simplify this and turn it into an easier problem, but that doesn't always work. So sometimes we just have to factor it the way it is. And that's okay. We know how to do that. It's difficult and we have to try a lot of different options, but it can be done. Today in class, we are going to practice this. There are 16 practice questions over 2 pages. We might not get to all of them, but we're going to see how many of these we can do today. So at the start of class, I'm going to go over about 3 or so examples with you together. And then we're going to spend the rest of the class just working these out independently and seeing how far you guys can get on your own. But of course, I'm here to help you do that. I'll be walking around, checking your work, answering your questions to make sure that we're all getting these right. So let's start by doing number 1 together. When your expression starts with a number, like a 2x squared, the first step we always try is we try to divide by that number. So I'm going to try to divide my entire expression by 2 to see if it can simplify. We have to divide every term on the left and every term on the right. Remember, both sides of the equal sign. And if all of your division results in whole numbers, then we're good, and it works out just fine. So this example does happen to result in all whole numbers. So when we divide everything by 2, we get x squared minus 4x minus 12 equals 0. This is a much simpler problem to factor. So we can draw our grid, fill the top left in with x squared, fill the bottom right in with negative 12, and then we start to come up with our factors. So I'm going to fill in the top with an x and the left with an x because we need x times x to give us x squared. And then we can come up with a list of numbers that multiply together to give us 12. One of those numbers will have to be a positive and the other one will have to be negative because they have to multiply together to give me a negative 12. So our list includes 1 times 12, 2 times 6, 3 times 4. Since it's a positive and a negative, our signs are different. We are looking for a difference that equals this middle term, negative 4x. So go down your list and try to find 2 numbers that have a difference of 4. 2 and 6 have a difference of 4, so let's use those. And now we need to figure out which one's positive and which one's negative. So inside my boxes, if I choose 2 and 6, I should have a 2x and a 6x. Which one of these do I want to make negative in order to get a negative 4x in the middle? We want the 6x to be negative and the 2x to be positive. Now that we have this factored, we've kind of double checked ourselves, made sure this all adds up right, we now rewrite our equation in factored form. So that would be x plus 2 times x minus 6. And this factored form makes it really easy for us to find our roots. Our roots are going to be the opposite signs, so negative 2 and positive 6. And that concludes example 1. So once you use the trick where you divide everything by 2 and it simplifies your problem, this becomes a very easy one for us to factor because we've been practicing these so much, we can factor these almost in our sleep by this point. But what I want to do next is take a look at an example that might not simplify so nicely. So I'm going to jump around here. Let's skip down to number 5, and we'll do number 5 together. Number 5 starts out with a 3x squared. So ideally, I should be able, well, I'm at least going to try to divide everything by 3 to see if it simplifies. But once I write that out and just take another look at my problem, I see that that's not going to work. Unfortunately, this second term, the 7x, cannot be divided by 3. We'd get a decimal number or a fraction, and then it would become extremely difficult to factor this. So we're not going to be able to divide by 3, which stinks, because that means now we just have to factor this the way it is. So we draw a grid, our 2x2 generic rectangle, and inside our generic rectangle, we fill the top left box in with a 3x squared. And we fill the bottom right box in with a -6. So now it's time to start thinking about what our factors need to be. Let's look at the 3x squared first. We need to come up with two things that multiply together to give us 3x squared. So fortunately, we only have one option here. Keaton, will you please get your mask up over your nose? Make sure it stays there. We need to come up with two things that multiply together to give us 3x squared, and we fortunately only have one option. 3x times 1x. I'm going to write that as 3x times x. And then we move on and we start looking at what we would need to multiply together to give us a -6. So those two numbers are going to have to be 1 times 6 or 2 times 3. But because it's a -6, we're going to need one of those numbers to be a plus and one of those numbers to be a minus. When your signs are different, you're looking for a difference to equal this middle number, -7x. Well, the difference between 1 and 6 is 5, and the difference between 2 and 3 is 1. Neither of those differences is 7. But remember, something strange is going to happen in these problems. Because of this 3x that's part of one of our factors, what ends up in this box on the top right is going to be different than what we might expect because it gets multiplied by 3x. So as we're marching through our options and trying out different combinations of numbers, pay close attention to that top right box. So this practice becomes a little bit like guess and check, trial and error. So we're going to guess 1 and 6. That would give us 3x, notice the 3x, how different it is because of what we're multiplying by, and 6x. Is the difference between 3x and 6x 7? No. So these aren't going to work. Let's try switching the 1 and the 6. We have to try them in both orientations because you get different answers depending on which number you put in the position that gets multiplied by the 3. So if we rearrange these and put the 6 on the top and the 1 on the left, we end up with an 18x and a 1x. That's way off. The difference between 18 and 1 is 17. All right, so we tried 6 and 1, and we tried 1 and 6. You have to try it both ways. But neither way worked, so we can cross it off. Moving on, let's try 2 and 3. So if we put the 3 here and the 2 here, let's just try this first. We end up with 9x and 2x. What is the difference between 9x and 2x? 7x. Okay, we're getting closer. Specifically though, we need it to be a -7x. So we need the 9x to be a negative number and we need the 2x to be a positive number, which is going to give us a +2 and a -3 in our factors. So trace those negatives back to where they would have needed to be to give you these answers. And we can rewrite this in factored form. Our two factors are x minus 3 times 3x plus 2 And from here, we can find our two roots. So I'm going to actually write this one out. The type of logic we use to find our roots is, okay, we've got these two factors multiplied together, and they equal 0. If two things are multiplied together and it equals 0, one of those things has to be 0. So maybe it's the first factor that's equal to 0. That would be x minus 3 equals 0. Or maybe it's the second factor that equals 0, which would be 3x plus 2 equals 0. We can solve both of these little mini equations for x. For the first one, I would just add 3 to both sides. So you get x equals 3. On the second factor that we have set equal to 0, I'm going to have to do more steps. First, you have to subtract 2 from both sides. And then you have to divide both sides by 3. So we've got a multi-step solve here that gives us a fraction as an answer. Our answer will be x equals negative 2/3. So this problem required us to have to try a bunch more options than usual, but it wasn't too terrible because in order to end up with a 3x squared in the top left box, we had one option. We had to use 3x times x. That was the only choice. There are no other numbers that multiply together to give you 3x squared. There are problems, however, where you have more than one choice. And so for that reason, together as a class, I want to do number 7 really quick. So look down right below this at number 7. If we try to simplify this by dividing everything by 4, unfortunately that's not going to work because we would end up with decimal numbers. So scratch that, and we have to go straight into factoring. Our first term is a 4x squared. So draw your rectangle, and in the top left box, place a 4x squared. In the bottom right box, we'll have a negative 5. So think about this for just a moment. If we need two things that multiply together to give us 4x squared, what are our options? Can I get a volunteer to tell me just two things that multiply together to give me 4x squared? Grace? Great. So Grace identified both options. We could have 2x times 2x or 4x times 1x, which means we can't just automatically fill in those two blanks. We're going to have to think this through. It's kind of tough to have to think about everything all at once, though. So what I tend to do is I tend to say, okay, I'm just going to guess first. We're going to try the options. We're going to guess, see if it works. And if it doesn't, we're going to erase it and we're going to guess a different option. So between 2 times 2 and 1 times 4, which one should we start with? It really doesn't matter. Can I get some people to vote? Who wants to start with 2 times 2? Who wants to start with 4 times 1? Okay, we'll start with 4 times 1. So that would mean I'd have a 4x and a 1x here and here. We don't have to write 1x, we can just write x. And then we need to make a list of numbers that multiply together to give us negative 5. Our numbers are going to have to be one positive, one negative. But then numerically, the only option to get 5 as a product is 1 times 5. When we're trying to decide where to put them, it might just be easiest to kind of throw them into a certain option and then check. So we know we need the numbers 1 and 5. If I put 5 here and 1 here, we get 4x and 5x. Is the difference between 4x and 5x 19x? Absolutely not. This doesn't work. Try switching the 4 and the 5. So we'll have, or I'm sorry, try switching the 1 and the 5. I said 4 and 5. So when you switch the 1 and the 5, then you end up with 20x and 1x. Is the difference between 20x and 1x 19? Yeah, we're getting closer. Okay, so this looks a lot better. All that's left is to figure out which one needs to be negative and which one needs to be positive in order for them to add together to give us negative 19x. So we got lucky on that one, and it just so happened that our first guess was correct. But let's say it didn't work. Let's say we tried the 4x and the 1x both ways and we couldn't get it to work. We would have to cross this off our list and try the next one. So we'd be erasing everything back to basically the start and starting over with 2x times 2x. So I wanted to do this problem together so that you could see that in these types of problems, we're used to having a lot of options for this bottom number. In every example we've done so far, we've had some options that we can choose from. We're not used to seeing options for the top left number, but you can have situations where there could be multiple ways to write that out. For instance, problem 8 on this page is going to have something similar to this. Okay, so that's all I wanted. Wait, let's finish number 7. I'm sorry. We're going to write this in factored form, x minus 5, 4x plus 1. And then you find your roots. And I'm going to cheat on this one and use the shortcut. What you do is you switch your signs. So the first factor will give us a root of positive 5. And the second factor will give us a root of negative 1 over 4. Negative 1 over 4. That's a pattern that you might come to recognize. Could save you some time. With the rest of the class period, I want you all to try these problems. I definitely want everybody to finish through number 8 at least, but I think that most of the people in here can get done through 16 as well. I can see some people have already started working ahead. Please try to get as many of these done as you can today. I will be around to check your work. I'll answer your questions and I'll help you fix mistakes if you happen to have any. All right, class, we don't have very much time left. I was walking around checking everybody's answers, and you guys are doing just excellent. Really, really great on these. So I don't feel the need to work out every problem and show you all the steps, but what I am going to do is I'm going to write the answers for each one. You can use those answers to check your own work. When you eventually turn this packet in, so it'll be next week because we're going to take our learning check next week. When you turn your packet in next week, I'm going to grade these based only on the first page. So I want you guys all, I want everybody to do numbers 1 through 8. And I'm going to write the answers down for 1 through 8 to make sure you have these and you can check your work. So the answer for number 2 is x equals negative 3 and x equals positive 2. So check your answers. If you got them wrong, make a note of what the real answer is so you can go back and try to find your mistake. For number 3, the answer is x equals negative 2, x equals negative 1. Those are your 2 roots. For number 4, you should get x equals 4 and x equals 1. We already did number 5 together. Number 6 is x equals negative 1 and x equals negative 3 halves. I saw quite a few mistakes on this one with the factoring. Your factors should be x plus 1 and 2x plus 3. I saw a lot of people who had mixed up the 1 and the 3, put them in the wrong spots. I saw a few people who tried to use other numbers other than 1 and 3. So you have to be careful. Make sure all of the pieces of your grid fit together after you put your stuff back in there. So I recommend checking your answers by combining all those terms back together and looking at them. All right, number 8. Number 8 is tricky. I'm actually going to do number 8 with you. So I want eyes up on the board. Oh, 1 second.
Teachers, pardon the interruption. This message is for Ms. Mayer's fourth period class. Those students need to go straight to room CC2. You will be having second lunch today instead of first. Again, Ms. Mayer's fourth period, go straight to CC2 for fourth period. Thank you.
All right, so we're gonna do number 8 together as a class. Here's why. This doesn't simplify, so we're gonna have to factor starting with a 10x squared. But we have options to do that. So you draw your grid and you put a 10x squared in the top left box, and you put a -2 in the bottom right box. In order to get a 10x squared, we're going to have to come up with two things that multiply together to give us 10x squared, but we have choices. It might be 1x times 10x, or it might be 2x times 5x. We don't know which. It could be either, so you might have to try them both. So I'm going to try 10x and 1x first. I usually put them in the other order. We'll do this. I'll try 10x and 1x first. Now for my numbers, I'm going to need a 1 times 2, and one of my numbers will have to be a plus and the other one will have to be a minus, which tells me that I'm looking for a difference that equals -1x. A difference. Okay, so if I put the 10x and the 1x in here, I might throw the 2 and the 1 in these spots, which would give me a 20x and a 1x. Don't think so. The difference between these is obviously not 1x. So erase, erase. Let's try switching the 1 and the 2. So we'll put the 1 on the top and the 2 on the left. That still gives me a 10x and a 2x. The difference between these things is still not 1x. So this is not working either. I tried 1 and 2, and then I tried 2 and 1. Neither of them worked. That means I need to cross this off my list. But it's the only thing on the list. So what does this mean? That nothing works and this problem is unsolvable? No. We tried 1x times 10x. It was a bust. Erase everything. Go back to the start and retry this problem with a 2x and a 5x instead. So we'll do a 2x times 5x now and see if this works any better. So we already know that our two numbers have to be 1 times 2. So let's try 1 and 2. If we put them in these positions, we end up with a 2x and a 10x. That's not going to work. Our difference between 2x and 10x is not 1x. So one more time, we've got to try to switch them. We'll put a 2 here and a 1 here. We end up with a 4x and a 5x. Finally, we ended up with two numbers whose difference is 1x. So now let's figure out where our pluses and minuses go. We need these two blue numbers to add together to give us a -1x. So the 5 has to be negative and the 4 has to be positive, making the 1 a negative and the 2 a positive. Be careful as you rewrite this in factored form. I'm seeing students who are doing the factoring 100% correctly, but then they're writing the factored form out wrong because they're getting their numbers mixed up with each other. Just be careful. This is one of our factors, 5x plus 2. This is the other factor, 2x minus 1. And then you end up with your roots, which are 1/2 and -2/5.